So hello, I'm audible. Yeah, everyone, I'm audible. Yes, audible. Okay, thank you. So hello, बच्चों, how are you? Good morning, everyone. I hope your preparation is going very well. So I'm Mohan Kumar Manglam. In this video, I will discuss with you kinds of a function. So before this lecture, I have already completed types of function and how to find domain and range of a function, and definition of function also completed. So in this lecture, I will discuss with you kinds of a function. So before discussing kinds of a function, first I will give you recap of previous lectures like definition of function. So I have already completed, but again in this lecture I will revise once again definition of function, domain, range and codomain of function. Then after that I will discuss with you kinds of a function. So now everyone tell me what is function. So what is function here? So first I will write here definition of function. So what is function? Anyone? Can me tell me? Can you tell me everyone? Anyone? Okay. No problem. Let me write first here. So function is a relation from set A to set B such that all the elements of set A must be connected to set B, or we can say in another words like this. So function is a relation from set A to set B such that all the elements of set A must be connected to unique element of set B. This is called function. So I am writing here definition. So function is a relation. So function is a relation. Function is a relation from set A to set B. Set A to set B such that all the elements of set A connected to unique element of set B, connected to unique element of set B. So this is called function. So function is a relation from set A to set B such that all the elements of set A must be connected to elements of set A, set B. So here in this, so this definition have to satisfy two conditions. So all the elements of set A must be connected to set B. So first condition here, so all the elements of set A must be connected to elements of set B, unique elements of set B. And second condition is, what is second condition? Second condition is elements of set A must not connected to more than one element of set B, or you can write like this. So elements of set A should not connect to more than one element of set B, should not connect to more than one element of set B, set B. So these two condition must satisfy, then relation becomes function. Otherwise this will not be a function. So you have to remember this condition. So I have already discussed and how to define function. So vertical line test, all these things I have already completed in previous lecture. So this is lecture number 5. Okay. So here just I am revising here so that I will discuss here kinds of a function chapter. So now suppose if I am taking here one function, like this function is defined from natural number to natural number such that fx is equal to x plus 1. So this is set A and this is here set B, and this is set of natural numbers. Set of natural numbers. So element must be 1 2 3 4 like this. Suppose so 1 2 3 4 5 given. So here also 1 2 3 4 5 6 given. So how this set A to set B is connected? So fx is equal to x plus 1. So from set A to set B connected y is equal to x plus 1. So what is meaning of this y is equal to x plus 1? So in this in input I have to add 1 so that I will get output. So if I add 1 in 1, so output will be 2. So 2 plus 1 3. 3 plus 1 will be 4. 4 plus 1 will be 5. 5 plus 1 will be 6. So this is called function. So here all the elements of set A are connected to elements of set B, and also one element of set A is connected to only one element of set B, or element of set A is connected to only one element of set B. So these two conditions are satisfying here. So this is a function. So this is a function. So now tell me here, so what is domain? I am just revising. Already everything I have completed in previous lecture. So what is domain? So elements of set A is called domain. So complete element of set A is called domain. So elements of set A. So elements of set A is called domain. So what is domain here? So domain is equal to 1 2 3 4 5 na. So 1 2 3 4 5. So what is range here? So sorry, first write here codomain. So what is codomain? So what is codomain? So elements of set B is called codomain. So elements of set B is called codomain. So what is here? 1 to 6. So this becomes here 1 2 3 4 5 6. So this is called codomain. Now tell me everyone, what is range? What is range here? So what is range? So elements of B which are connected to elements of set A is called range. So elements of set B which are connected to elements of set A, which are connected to elements of set A, is called range. So what will be range here? So range is equal to, see, one is not connected with any element of B, no? Sorry, one is not connected with any element of A. So my range is here 2 3 4 5 6. So this is range here. So range is equal to 2 3 4 5 6. So this is range. So this is range here. So you can mark here like this. So this is domain here. Complete set of A. Complete element of set A is called domain. So this is called codomain. You can write like this. And elements of B which are connected to elements of set A is called range. So this white line, this is called range here. So this is called range. So now I have revised with you definition, domain, range and codomain of a function. So now today today I will discuss with you kinds of a function. So my main lecture is today is kinds of a function. So now kinds of a function. So kinds of function. So there are mainly four kinds of function. So there are mainly four kinds of function. So there are mainly four kinds of function. Four kinds of function. So what is four kinds of function? First is one-to-one function. First I will write the name, definition. After that I will discuss some questions. So in math, theory is not asking, but I am explaining here theory part first. After explanation of theory I will discuss questions. and questions I will discuss JEE advanced question and mains question. So after giving you definition of all these kinds of function. So first is one to one function, second is many to one function, second is many to one function, third is on to function, third is on to function, and fourth is into function, fourth is into function. So there are mainly four kinds of function, and in next video I will discuss here number of one function, number of many to one function, on to function. Clear? So that question is very important. So now, so here two functions, starting name here O. So here one functions, another name is also injective function. So this is also called injective function, and onto function is also called surjective function. So onto function is also called surjective function. So those functions name starting with O you can remember like this. So injective and surjective. And one more point you can write here, those function injective and plus surjective, injective plus surjective. So this function is called bijective function. So this function is called bijective function. And those function which is bijective is invertible function. So what is meaning here? So those function which are injective and surjective is called bijective, means functions are invertible. So then functions are invertible function. So invertible function. What is meaning of this? What is meaning here? So invertible means inverse of this function will exist. You can write like this. So inverse of function will exist. Inverse of function will exist. You can write like this. Okay. Okay. So there are mainly four kinds of function. Any confusion up to here? I am going little bit fast because here these things is very easy. This is only theoretical part. But when I will explain question, then I will be very slow. Okay. So now first is one to one function. So first is one to one function. First is one to one function. So first is one to one function. So what is one to one function? So now tell me everyone, what is one to one function? So if one element of A is connected to only one element of B, then function is called one to one function. You can remember like this. If one element of set A, if one element of set A is connected to only one element of set B, only one element of set B, then function is called one to one function. Then function is called one to one function. So what is meaning here? So one element of A is connected to only one element of set B. Means you can say in Hindi like this, एक तीर एक को लगेगा तो उसको हम क्या बोलेंगे? One to one function. Suppose a function is defined from n to n, natural number to natural number, and such that fx is equal to x plus 1. Fx is equal to x plus 1. So what kind of this function? So I am writing here, suppose function is defined from natural number to natural number such that fx is equal to x plus 1. So this is one to one function. How? You can say like this. See. So this is natural number to natural number defined. 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5, 6 like this. Given. So function is defined y is equal to x plus 1. So from A to B like this. Okay. So in 1 add 1. So this is 2. This is 3. So this is 4. This is 5. This is 6. So here one element of set A is connected to only one element of set B. So this is called one to one function. So this is called one to one function. Okay. So now next is, any confusion up to here? Can I move to next part here? Okay. Second is many to one function. Second is many to one function. Second is many to one function. So this topic is very easy, but questions are asking very interesting question asking based on this topic. So next lecture will be very interesting. So in this lecture I am only explaining theoretical part, and after theoretical part I will discuss 2-3 important questions, JEE mains and advanced question, and in next lecture I will discuss some of the good questions of JEE mains and advanced again. So what is many to one function? So what is many to one function? So if one or more than one element of A is connected to only one element of B, so you can write here, if two or more than two elements of set A, two elements of set A is connected to one element of set B, one element of set B, then function is called many to one function. So then function is called many to one function. Then function is called many to one function. I'm writing in short form, many to one many to one function. So suppose example, if I'm taking one example, function is defined from natural number to function, I'm taking one example, function is defined from integer to integer such that fx is equal to x square. So what is this here? So this is set A and this is set B. Function is defined from integer to integer. So here, so this is -2, -1, 0, 1, 2, 3, like this. So again here, so -2, -1, 0, 1, 2, 3, 4, like this. So how function is defined here? So y is equal to x square. That is y is equal to x square. So I have to do a squaring of input. No? So what is value? -2 square. -2 square will be 4. -1 square is 1. 0 square is 0. 1 square is 1. 2 square is 4. So now you can see in set B. So 1 is connected to two elements of set A. 1 is connected to two elements of set N. -1 and 1. Output is only 1. Like this, like same here, -2 and +2. Output is 4 only. So this function is called many to one function. So here two element of set A is connected to only one element of set B. So this is called many to one function. I hope up to here clear. Any confusion up to here? Okay, no problem. So can I discuss next? Third is onto function. So third is onto function. So this color is visible? Okay, yes. So third is onto function. So now tell me onto function. What is onto function? This is also called surjective function. So what is onto function? Anyone? Okay, no problem. So what is, yes, range is equal to codomain. Or you can say like this, if all the elements of set B is connected to elements of set A, then function is called onto function. So I'm writing in detail the definition. So if all the elements of set A, if all the elements of set B is connected to elements of set A, connected to elements of set A, then function is called onto function. Function is called onto function. Clear? Or you can remember like this: if range is equal to codomain. So you can write here like if range is equal to codomain. Then function is onto function or surjective function. FUNCTI. So then onto function. So now later I will discuss how to find onto and into functions. So you already know how to find range, yes or no? So later I will discuss with some example how to decide onto and into function. So now next is into function. So what is into function? Fourth is into function. So if all the elements of set B is not connected to elements of set A, then function is called into function. If all the elements of set B, is not connected with elements of set A. Clear? Set A, then function is called into function. In short, you can write like this: if range is less than codomain. So if range less than codomain, so then function is called into function. So okay, now I have completed this definition part, so very fast. So now I will discuss some questions. So now my next topic is how to decide kinds of a function. This is very, very important. After this, whatever I will discuss, that is very, very important. Till now I have discussed some only theory parts, and this theory part is not useful, but you have to know the definition of this theory part also. Okay, so now my main topic is how to decide kinds of a function. How to find kinds of a function. So how to find kinds of a function. Okay, so there are three methods. I will discuss here to decide kinds of a function. So there are mainly three methods to decide kinds of a function. So first is by mapping method. Second is by graphical method. And third is by dy by dx. Method. So by dy by dx method. Okay. So there are three methods to decide kinds of a function. First is mapping method, second is graphical, and third is dy by dx method. So I will discuss mainly these three kinds of a function. Mathematically also you can derive kinds of a function, but I will discuss these three methods to decide kinds of a function. So first is here by mapping method. So how to decide? So when to use by mapping method? So my question is here, when to use mapping method? So if function is given like this, function is defined from natural number to natural number like this, like real number to integer, or function is given integer to integer, integer to natural number. So generally, if function is in question, if questions are given like this, function is defined from natural number to natural number, real number to integer, or integer to integer, or real to real, like this. So then you can use this mapping method. Okay, so I'm writing one question. So by solving question, you can understand how to decide kinds of a function here. So I'm taking one question like this. Suppose a function is defined from, so this red color is visible? Yes, yes, visible. Suppose a function is defined from natural number to integer. Function is defined from natural number to integer such that fx is equal to n minus 1 divided by 2 when n is odd, and this is equal to minus n by 2 when n is even. When n is even, then comment on kinds of a function. Then comment on then comment on kinds of function. Comment on kinds of function. So how to solve this kind of question? So I will use here mapping method. Clear? So I will use here mapping method. So function is defined from natural number to integer. Okay, function is defined from natural number to integer. So set A is set of natural number and set B is set of integers. So I'm writing natural number 1, 2, 3, 4, 5, 6 like this, and integer will be like this, like minus infinite to like minus 4, minus 3, minus 2, 1, 0, 1, 2, 3, 4 like this. So how this function how this function is defined from set A to set B? So fx is equal to n minus 1 by 2 when number is odd. So I'm taking 1. So 1 is odd or even? So 1 is odd. So if function is odd, I have to use this formula na. So n minus 1. So 1 minus 1 divided by 2. So 0. So this becomes 0. So 1 is going to 1 will connect with 0. So next I am taking 2. 2 is even. So when number is even, which formula I have to take here? Minus n by 2. So minus 2 by 2 minus 1. So minus 1. Oh sorry. So this 2 will connect with minus 1. Here minus 1. So this 2 will connect with minus 1. Minus 1. Now I am taking 3. So 3 is even or odd? Odd. Odd means n minus 1 divided by 2. So 3 minus 1. 2 divided by 2. So 3 will connect with 1. 3 will connect with 1. I am taking 4. So 4. So minus n by 2 na. So minus 4 by 2. So minus 2. So 4 will connect to this minus 2. Now I am taking 5. So 5 minus 1. 4 divided by 2. So 5 will connect with 2. So 6 will connect with. So minus 6 divided by 2. Minus 3 na. 6 will connect with this. So like this now you can comment here. So which kind of function here? So now in this way you can draw here infinite arrow. Okay. So now I'm commenting on types of kinds of a function. So now see here. So one element of B is connected to only one element of set A. Only one element connecting na. So this is here. So one element is connected with only one element. So 1 to 1 function. Now tell me, onto function or into function? So now every element of B will connect like with the help of this formula na. So every element of B will connect with elements of A. So here range is equal to codomain. So here range is equal to codomain. Codomain. So this is onto function. So this is onto function. Very simple. So this is 1 1 plus onto. You can write like this. So this is 1 1 plus onto function. This is 1 1 plus onto functions. Like this you can solve by mapping method question and you can comment on kinds of a function. I hope here your doubt is clear here. Any confusion? Anyone? Okay, no problem. So first method I had explained here by mapping method. So now you can solve here lot of question. By solving lot of question, you will get idea which method I have to apply here. So now next I will discuss by dy by d by graphical method. Second is my graphical method. So second is graphical method. Second is graphical method. Second is graphical method. So this method you use only when you know the graph of a function. So only use when you know the graph of a function. Only use when you know the graph of function. When you know the graph of the function. Clear? Any confusion? So now after drawing graph, what you have to do? So draw one line parallel to x-axis. Clear? So draw line parallel to x-axis. Parallel to x-axis. And if this line cuts the graph only one time, then function will be 1-to-1 function. Otherwise, many to one function. So if this line cuts the graph only one time, then function is 1-to-1 function. Then function is 1-to-1 function. Otherwise many to one function. Otherwise many to one. Clear? Any confusion? So now I will solve questions. By solving question, now you will understand here how to apply this method here, graphical method. Suppose one question is given like this. Function is defined from 0 to pi and this given -1 to +1 such that fx is equal to sin x. Fx is equal to sin x. Now comment on kinds of function. Now comment on kinds of function. Comment on kinds of function. So now solve everyone and tell me answer. So how to decide here kinds of function? So first I have to draw the graph fx is equal to sin x. Fx is equal to sin x graph. So from where to where I have to draw? So this side will tell me from where to where I have to draw the graph, 0 to pi. So this function is domain is 0 to pi only, na? Yes or no? So fx is equal to sin x. I have to draw the graph of fx is equal to sin x from 0 to pi. So now tell me what will be graph of fx is equal to sin x from 0 to pi. So this is 0, this is pi by 2. So this is pi, na? So 0 to pi, what is graph of sin x? This is graph of sin x, na? So this value is 0 and this value will be +1. +1, na? So this is y is equal to sin x from 0 to pi. So 0 to pi only I have to draw the graph. Here function is defined from 0 to pi only, na? So 0 to pi I have drawn the graph. Now what you do? Now draw the horizontal line parallel to x-axis. Now I am drawing horizontal line parallel to x-axis. Now check this graph is cutting how many times. So this horizontal line cutting this graph at two places, na? So at 2 times this graph is cutting, means this is many to one function. So what is meaning of this? What is meaning? Meaning here means at 2 input output is same. So what is meaning here? So at 2 input output is same, means 2 input giving same output. That is why this is many to one function. So this is many to one function. So now tell me onto or into function. So what is codomain given? -1 to +1 given. Given na? So codomain is given -1 to +1. But what is range here? So here range. So here range is equal to 0 to +1. So range is equal to 0 to +1. So this is not is equal to codomain. So range not is equal to codomain. So range is not is equal to codomain. Any confusion up to here? So this function is into function. So this is into function. Any problem? Everyone? Okay, no problem. So can I write next question? Yes. So now again suppose one more function I am writing here. So this time function is defined from -π/2 to π/2. And its range is codomain is -1 to +1. And function fx is equal to sin x given. Fx is equal to sin x given. Then comment on kinds of function. So then comment on kinds of function. Comment on kinds of function. So now tell me, who will tell me answer here? First, tell me first answer. So this time function is defined from where to where? -π/2 to +π/2. And I have to draw the graph of fx is equal to sin x from where to where? Minus sin x to plus sin x. But in previous question, what is given here? Function is only defined from 0 to pi. So that is why I have drawn graph from 0 to pi only. But this time function is defined from -π/2 to +π/2. So now draw the graph of this function from -π/2 to +π/2. So this is 0. So this is π/2 and this side is -π/2. So what will be graph here? So sin x graph is like this. From -π/2 to π/2, sin x graph. This is not a straight line. Clear? Sin x graph is this. So this value is +1. This value is -1. I have to draw the graph between -π/2 to +π/2 only, because here in question given domain -π/2 to +π/2 only. Clear? So I have drawn the graph of fx is equal to sin x from -π/2 to +π/2. So any confusion up to here? No confusion, sir. So now what you do? Draw one horizontal line parallel to x-axis. So now I am drawing here. Now again here draw. So this one line is cutting this graph only one time, na? So only one time cutting here. So this function is 1 to 1. So this function is 1 to 1 function. So now check here range. So this graph is from -1 to +1. So this range. So this range is -1 to +1. So this is equal to codomain. So this is equal to codomain, na? So here codomain given -1 to +1. So this is onto function. So this is onto function. So now tell me, in inverse trigonometric function, we have already discussed this, na? Function is defined from -π/2 to π/2, -1 to 1. So this is invertible function. So this function is invertible now. Y is equal to sin x from -π/2 to +π/2. So this function is 1 1 and onto. And those function which is 1 1 and onto is invertible function. So that is why y is equal to sin x from -π/2 +π/2 has a inverse of this function, sin inverse x. From where to where? -1 to +1. And range that become inverse function range -π/2 to +π/2. So that is why we have discussed all these things in inverse trigonometric function chapter. Clear na? So this function is bijective. So this function is bijective. So I hope. So now any doubt up to here? So I hope your doubt is clear. Yes or no? So now can I move to next part here? So next is dy by dx method. Third is dy by dx method. So next is dy by dx method. Third is. Third is dy by dx method. Any confusion up to here? Okay, no problem. So now third is dy by dx method. So now tell me here. So if dy by dx greater than 0 or dy by dx less than 0 only without any condition, dy by dx greater than 0 or dy by dx less than 0 only, then function is 1 to 1 function. Yes or no? Right everyone. Okay. So if dy by dx greater than 0 or dy by dx less than 0 only, then function is 1 to 1 function. If dy by dx greater than 0 and dy by dx less than 0 conditionally, then function is many to one function. So then function is many to one function. Any problem? So then function is many to one function. Any problem? Okay, so now I will discuss with some example here. So now my question is, first question is here, fx is equal to, okay, I am writing here, function is defined from R to R such that fx is equal to x cube plus x. Fx is equal to x cube plus x. Here comment on kinds of a function. Comment on kinds of function. Comment on kinds of function. So how to decide kinds of function? So this color is visible, no? Yes, visible. Okay, I will write with white color. So this function is defined from real number to real number. Clear? R to R. And fx is equal to x cube plus x given. Given, no? So comment on kinds of function. So how to solve here? So again see here. So fx is equal to x cube plus x. So what is f dash x? F dash x is equal to 3x square plus 1. So 3x square plus 1. So now tell me sign of f dash x. So put any value of x. So this is positive always, no? So without any condition, if you put x is equal to 0, so this is 1. 1 is positive, no? So without any condition, f dash x is positive always. Positive always, no? So this f dash x is greater than 0 always. Means fx is increasing. Fx is increasing always, no? So this function is 1 to 1 function. So 1 to 1 function. So now tell me onto or into. So now this is odd degree polynomial, no? So odd degree polynomial has range minus infinite to plus infinite. So this is odd degree polynomial. So range is minus infinite to plus infinite. So range is equal to R. So this is equal to codomain. So this is equal to codomain, no? So this function is 1 to 1 plus onto. So this function is onto function. I am not fast, no? Any problem anyone have? No problem. Okay. So onto function. So this is a onto function. Next again I am taking one more question. Same question. So again I am taking fx is equal to x cube minus x and function is defined from R to R. Okay, let me write here. So function is defined from R to R such that fx is equal to x cube minus x. X cube minus x. Now comment on kinds of function. Now comment on kinds of function. Comment on kinds of function. Now tell me. Now you solve by yourself and tell me answer. Clear? Tell me answer. So what is fx given? Fx is equal to x cube minus x. So what is f dash x? F dash x is equal to 3x square minus 1. So now tell me here what will be sign of f dash x here. Someone saying positive always. Someone saying negative. Okay, okay, correct. Now tell me here. When I put value of x is equal to 0, so this becomes less than 0 na. So if x is equal to 0, so f dash x is less than 0. Clear na? And if x is greater than 0, I am putting 1. So f dash x greater than 0 na. So this function is conditionally. So this function f dash x is conditionally positive negative na. So this function is fx is many to one function. Clear? So many to one function. Many to one function. Now tell me everyone. So onto or into function. So now see here again. So this is odd degree polynomial. So range here. Range is equal to minus infinite to plus infinite. So this is equal to r. So this is again onto function. So this is onto function. So this is many to one and onto function. Clear? So write one homework question. So I am giving you one homework question. So write here. So write here homework question. So fx is equal to x square plus mod x. Sorry. Fx is equal to x plus mod x. Clear? Then comment on kinds of function. Next question is fx is equal to x minus mod x. And next question is fx is equal to x into mod x. These three questions I am giving you homework. Clear? These three questions I am giving you homework question. So you have to solve. Clear? So next question I am going to solve here JEE advanced question. And this is very, very important question. Okay. So what is given here? One question is given here like this. A function is defined from R to R such that fx is equal to mod x x minus sin x. Clear? Mod x x minus sin x. So comment on kinds of function. Comment on kinds of function. Comment on kinds of function. Comment on kinds of function here. After this, I will give you one homework question again. Interesting question. So now tell me, function is defined from R to R and fx is equal to mod x into x minus sin x. So you have to decide here which type of function, that is which kind of function, 1, many to one, onto or into. So now tell me which method I have to apply here. So I will apply mapping method. No, I will not go for mapping method. dy by dx method. No, here mod x is given. Graphical method. Again mod x is given. Yes, I will use graphical method. So before applying graphical method, first I will decide here. So this function is even or odd function. So first I will check even or odd. Why? So after deciding even or odd function, then I will draw the graph of this function na, based on value of x. If x is positive or negative. Yes or no? So I will use here two methods. First I will decide here this function is even or odd function. So now can I solve? So who will solve this question first? Tell me. Okay, no problem. I will discuss here. So first I will discuss here. So this function is even or odd function. So you know already I have completed how to decide even and odd function. So put in place of x is equal to minus x. So this fx is equal to mod x x minus sin x given na. So first decide here even or odd. First step I am writing here. So step 1. So decide here even or odd function. Clear na? Even or odd. So write here. So first fx is equal to mod x x minus sin x. So now replace x by minus x. I am putting x is equal to minus x. So what is f of minus x? Mod of minus x. Here minus x minus sin of minus x. Any problem? So mod of minus x, mod x only, no? So this is minus x. So this is mod x. So this is minus x. Sine minus theta minus sine theta. So this becomes plus sine x. Now what you do? Take minus common. So f of minus x is equal to minus mod x, x minus sine x. So mod x into x minus sine x is fx, na? Yes or no? So f of minus x is equal to minus f of x. So this function is odd function. So fx is odd function. So fx is odd function. So why I calculated here even or odd? Because after calculation, after deciding even or odd, so I will draw the graph, na? If function is odd, so graph will be symmetric about origin. Yes or no? If function is even, graph is symmetrical about y-axis. All these things I have discussed in graphical transformation. Yes or no? So now if function is odd, graph is symmetric about origin. Okay. So function is odd. So my first step is over. So my first step is over. Now second step. So this is JEE advanced question. So this is JEE advanced question. So now fx is equal to mod x, x minus sin x given. So now I will remove this mod. So I am taking case first here. So for case first I am taking x greater than 0. So if x greater than 0, so mod is removed, na? So f of x is equal to x into x minus sin x. So fx becomes x into x minus sin x. Now differentiate this function. So f dash x is equal to u into v. Apply u into v. So x into 1 minus cos x plus here x minus sin x. So now tell me here again, f dash x is positive or negative for x greater than 0. So if x greater than 0, now tell me. So this is positive and 1 minus cos x always positive, no? So this is positive. Now x minus sin x, tell me, positive or negative? So see here, sin x always less than x. Yes or no? I have discussed already these things also. Yes or no? So sin x is less than x here. So this is also positive. So positive plus positive, positive. So this is greater than 0. So f dash x is greater than 0 for x greater than 0. So fx is increasing function, na? For x greater than 0. So fx is equal to mod x, x minus sin x for x greater than 0 is increasing function. Now tell me again case 2. Now case 2, now tell me everyone. So if x is less than 0, so mod x minus x, na? So fx is equal to minus x into x minus sin x. X minus sin x. So now tell me. So now again differentiate here. So f dash x same, only minus sign outside, na? So I am writing directly here. So x into 1 minus cos x plus x minus sin x. X minus sin x, na? So this is already positive. So this is positive into negative. So this is negative, overall negative, na? So this side, this is positive and multiply by minus sign. So this becomes negative. So f dash x is less than 0. So f dash x is less than 0 when x is less than 0. So fx is decreasing function. So fx is decreasing function when x less than 0. So now my job is over now. So now, so what is conclusion here? So fx is odd function. In first step I have decided, na, fx is odd function. And in second step fx is, now tell me, increasing when x greater than 0 and decreasing when x less than 0. So based on these two conclusion, draw the graph here. So I am drawing the graph. I don't know exactly how, so I don't know exactly what will be graph, but if x is greater than 0, so function is increasing na. So function is increasing if x greater than 0. So same graph this side also na, function is decreasing when x less than 0. So graph will be like this, increasing when x is greater than 0, decreasing when x is less than 0. So now draw one line parallel to x-axis. So graph is cutting one time or two times? Graph is cutting only one time. So function fx is 1 to 1 function. 1 to 1 function. So now tell me here. So if I put x is equal to 0, function will be 0 na. So this graph is from minus infinite to plus infinite. So range here minus infinite to plus infinite. So this is equal to r. So range is equal to codomain na. So function is defined from, see, r to r. Here r to r given na. Function is defined from r to r. So here range is also is equal to r. So this function is onto function. So this is onto function. So what will be my answer? So fx is 1 to 1 and onto means bijective. So fx is 1 to 1 plus onto function. So fx is 1 to 1 plus onto function. So any problem up to here? Any problem? Okay, no problem. So now can I give you one homework question? Interesting question. Okay, so this is last question. I am giving you homework. You have to solve. In next lecture I will discuss this question. Suppose function is defined from r to r and fx is equal to x cube plus x square plus x plus gif x. Then comment on kinds of function. Then comment on kinds of function. Then comment on kinds of function. So question is visible na? So this is the question. This is homework question. So fx is equal to x cube plus x square plus x plus gif x. This question I am giving you homework. So this is homework question. Okay, thank you. So can I conclude the lecture? Yes, conclude, sir. Okay, thank you, everyone. Thank you for attending this lecture. Thank you, everyone. Okay, thank you.